Hi everyone, and we have completed successfully up to 12 lectures, and this lecture is lecture number 13, and we are continuing with the topic that is third chapter, coordinate systems. So we are solving some problems based on coordinate systems, right? Okay. So in this lecture we try to solve some more problems on the coordinate systems. So this is most probably this is the last lecture for coordinate systems, that is for third chapter, right? Okay. So now see here. Now see here, if suppose I have given a vector a bar, I have given a vector a bar as 2ax cap plus 3ay cap plus 4az cap, right? And I have given another vector b bar is equal to some 4ax cap plus 6ay cap plus 5az cap. Suppose I have given these two vectors, and if I ask you to determine what is a bar plus b bar, if I ask you to determine what is a bar plus b bar, okay, so you know that it is very simple, isn't it? So what you will do here, so you will just add the x components. See, why you are adding these two x components here, why you are not adding the x component and y component, why you are adding only x components? Why means, see here, if you consider this as y axis and this is x axis and this is z axis, right? Okay. So now see here, so here ax cap for this vector, ax cap is going to point along which direction here? It always points in a direction parallel to x axis, right? And here this 4ax cap, so this ax cap also is going to point in a direction parallel to what? Parallel to x axis. So whatever the point you can take in rectangular coordinate system, the direction of ax cap will be always parallel to x axis, the direction of ay cap will be always parallel to y axis, and the direction of az cap will be always parallel to z axis. Understood? So the directions of ax cap, ay cap and az cap are fixed. So whether you consider 2ax cap or you consider 4ax cap, here the ax cap here and ax cap here both are going to point in the same direction. So since both are pointing in the same direction, that's why we are adding these two components. Understood? So what you are going to get? You are going to get 6ax cap, right? Okay. Next, here you are having 3ay cap plus 6ay cap. So here ay cap and here ay cap both are pointing in the same direction. So both are parallel to what? Parallel to y axis only. Both are pointing in the same direction. It is ay cap, it is also ay cap. So that's why we are adding these two components, that is 9 into ay cap plus here az cap and here az cap both are parallel to what? Z axis only. So both are pointing in the az cap, both are going to point in the same direction. So that's why we are adding these two components. So what you are going to get? 9 az cap. So whenever you are adding the two components, so those two components must point in the same direction. Understood? Then only we can add those two components. Understood? Okay. So now see here, right? Okay. So now if I consider a vector in cylindrical coordinate system, so like let us say a bar is equal to, let us say 2 arrow cap plus 3a5 cap plus 4az cap. I have considered a vector a bar is equal to 2 arrow cap plus 3a5 cap plus 4az cap, and I am defining this point, I am defining this vector at point 3 comma 30 degrees comma 4. Okay, so at point 3 comma 30 degrees comma 4, I have defined a vector a bar is equal to 2 arrow cap plus 3a5 cap plus 4az cap. Next, at point let us say this point is a, right? Next, at point b, so that is let us say this is a 4 comma, let us say this is 4 comma 60 degrees comma okay, you can take okay, 5 or something, right? Okay, okay. So here at this point I am defining another vector. B bar is equal to 3 aero cap plus 4 a5 cap plus 5 az cap, right? Okay, okay. So now if I ask you to determine, a bar plus b bar here, if I ask you to determine a bar plus b bar, so this is equivalent to what? This is equivalent to, okay, so 2 plus 3 5 aero cap plus 3 plus 4 7 a5 cap plus 4 plus 5 9 az cap. Is this correct here? Is this correct? Tell me. So here if I ask a bar plus b bar, and if you just add these two components, then this is what? This is absolutely wrong. This is absolutely wrong. Okay. So why? Because this point A, this vector a bar is defined at point 3 comma 30 degrees comma 4. Right, and this point B is defined at point 4 comma 60 degrees comma 5. So let us say this is rho 1 and this is phi 1 and this is what? This is z1, and let us say this is rho 2 and this is phi 2 and this is what? Z2. Right, we know that the directions of aero cap and a5 cap are going to depend upon what? Are going to depend upon phi. Yes or no? We know that aero cap is equal to what here? Aero cap is equal to, we got cos phi ax cap plus sin phi ay cap, isn't it? Okay, whereas a5 cap is equal to what? Minus sin phi ax cap plus what? Plus cos phi ay cap. Right, we know that this aero cap direction and a5 cap direction are depending upon what here? Are depending upon phi values, are going to depend upon phi values. So as phi value changes, the direction of aero cap and a5 cap is also going to change. So which means you have defined this vector at this point. At this point phi 1 value is how much here? 30 degrees. Okay, at phi 1 value is 30 degrees, and here at another point 4 comma 60 degrees comma 5, you have defined another vector. Understood? So this vector is defined at a point 4 comma 60 degrees comma 5. So here the phi 2 value, is how much here? 60 degrees. So here the phi value, both are what? Both are different. So that means the direction of aero cap here and the direction of aero cap here is also going to be different, and the direction of a5 cap here and the direction of a5 cap here is also going to be different. So if these two directions are different here, the aero cap direction at this point is different, and the direction of aero cap at this point is different, because the phi values are different for these 2 points. So if phi changes, the directions of aero cap is also going to change. So here aero cap direction, both are not pointing in the same direction, both are not parallel to one another. Understood? Both are not going to point in the same direction. So that's why you cannot add these two components directly. Right. Similarly, a5 cap is also going to depend upon phi value. So since here the phi value and here the phi value both are different, the direction of a5 cap here and the direction of a5 cap here both are what? Both are different, and hence you cannot add these two components. Understood? So which means you cannot add directly this a bar and b bar, which are defined at two different values of phi, Understood? Okay. If suppose for example here we have considered the phi value as 30 degrees. Here also if I consider phi 2 also as 30 degrees. Okay, then here phi value, both are what? Both are same. So since here phi both are same, then in that case the direction of aero cap here and the direction of aero cap here will be in the same direction, and the direction of a5 cap here and the direction of a5 cap here will be in the same direction. In that case we can directly add these two vectors. Understood? If the phi values are different, then you cannot add the two vectors directly in case of cylindrical coordinate system. Understood? Okay. Okay. So not only in cylindrical coordinate system here, in spherical coordinate system also, in spherical coordinate system also. Okay, so in spherical coordinate system also, if you represent the vector, a bar, if you represent the vector in spherical coordinate system, if you represent the vector as a, let us say 2ar cap plus 3a theta cap plus 4a phi cap, I have represented like this. Next, b bar in spherical coordinate system, I have represented as a 4ar cap plus 5a theta cap plus 6a phi cap, like this. Understood? Okay, so now if suppose this is defined at 3 comma 30 degrees comma 45 degrees, and here this is defined at 2 comma 60 degrees comma 30 degrees. Okay, so here this is nothing but theta 1, sorry, so this is nothing but theta 1, and this is nothing but what, phi 1, and here this is nothing but theta 2, and here it is nothing but what, phi 2. We know that ar cap and a theta cap, are going to depend upon what, are going to depend upon both theta as well as what, as well as phi. And also we know that this a phi cap is going to depend upon what, is going to depend upon only phi, right? Okay, so since here theta and phi values in this point and theta and phi values for this point, both are what, both are different, and hence the direction of ar cap here and the direction of ar cap here both are different. Similarly, the direction of a theta cap here and the direction of a theta cap here is also different, and the direction of a phi cap here and the direction of a phi cap here both are different. So in this case you cannot perform directly the addition operation. Understood? When you can add the two components here, whenever those two components are pointing in the same direction. Okay, so then only you can perform the addition operation, right? So in this case also you cannot determine a bar plus what, a bar plus b bar, you cannot determine a bar plus b bar, right? Okay, okay. So this is the point you have to understand. So now see here, in a cylindrical coordinate system, I can explain this one here. See here, see they have represented the vector a bar 2 aero cap plus 3 a phi cap 4 az cap at point 3 comma 30 degrees comma 4, right? Okay, okay. So let us consider this is z axis, let us consider this is z axis, right? So here I am considering a circle here I am considering a circle, right? So we know that the circular planes are nothing but z equal to constant plane. So let us say here the z value is how much here? Z value is 4. Okay, so let us consider this is z is equal to 4 plane, z is equal to 4 plane. So here I am drawing a line that is parallel to what? That is parallel to x axis, that is parallel to x axis. Okay, so this is the line that is parallel to x axis. So I am just representing with x, no problem here, right? Next, what is rho value here? Rho value is 3, right? So this rho value is 3, rho value is equal to, this is rho 1 which is equal to 3, and phi this angle they have given, this phi 1 value they have given as what? Phi 1 value they have given as 30 degrees, right? So this is the point here, this is the point. So this point is at a normal distance of 3 units from the z axis, and it is at an angle of 30 degrees with respect to x axis, right? Okay, and this point is present in z is equal to 4 plane, that means z value is equal to 4. So this is the point I have located in cylindrical coordinate system. So at this point they have defined a vector, right? Okay, okay. Now see here, at this point aero cap is going to point in which direction? Aero cap is going to point along radial direction like this. This is aero cap. And what is a phi cap? Draw the tangent at this point. So this is nothing but a phi cap. And what is az cap? So az cap is going to point in this direction, right? So at this point aero cap is pointing in this direction, a phi cap is pointing in this direction, and az cap is pointing in this direction, right? Okay, okay. So now they have defined a vector a bar at that point. So the vector a bar, what they have defined? So the vector a bar is having 2 units along arrow cap direction. So that means here you can draw I cannot draw in space here, here you can draw a vector a bar, you can draw a vector a bar. So that vector a bar is going to have its component of 2 units along arrow cap direction. Okay, so the vector a bar is having 2 units along this arrow cap direction and 3 units along a5 cap direction and 4 units along az cap direction. Understood? A bar is having 2 units along arrow cap direction and 3 units along a5 cap direction and 4 units along az cap direction. So the resultant vector you are going to get something like this. Understood? Okay, so I hope it is crystal clear. Now they have given another vector b bar that is defined at what? 4, 60 degrees, 5, right? 4, 60 degrees, 5. So z value is what? Z value is 5 here. Z value is 5, right? Okay, okay. So let us consider this is the plane, right? So let us consider this is the plane. Okay, so let us say this is z is equal to what? Z is equal to 5. Right, and the radius of this one, the radius of this z equal to 5 plane, the radius of this z equal to 5 plane is nothing but what? 4 units, right? And phi 2 is 60 degrees, phi 2 is 60 degrees, right? So let us draw a line that is parallel to x-axis. Let us draw a line parallel to x-axis, right? Okay, so now here rho is present somewhere here, right? So this angle now, this angle is how much here? This angle is nothing but phi 2, which is equal to what? Which is equal to 60 degrees. So this is rho 2. Rho 2 is equal to 4 units, right? Okay, so rho 2 is equal to 4 units and z value is 5 and phi 2 is equal to 60 degrees. So now at this point arrow cap is going to point in this direction. Arrow cap is pointing in this direction and a5 cap is pointing in this direction, right? And az cap is pointing in this direction, right? Okay, so at this point we have defined a vector b bar, right? So that b bar is equal to what? 3 arrow cap. So 3 units along arrow cap direction, right? And 4 units along this a5 cap direction and 5 units along az cap direction. Understood? Okay, so you are having 3 units along arrow cap and 4 units along a5 cap and 5 units along az cap direction. So the resultant vector b bar is going to lie somewhere here. Understood? Okay, now if you observe here, the arrow cap direction here and the arrow cap direction here, both are what? Both are different, right? And here a5 cap direction here and a5 cap direction here, both are not parallel here, both are different, right? And az cap, only az cap is parallel to one another, whereas arrow cap and a5 cap are not parallel to one another. So arrow cap is not parallel to this arrow cap and here a5 cap is not parallel to this a5 cap, right? The direction of arrow cap here and the direction of arrow cap here, both are different, right? And also the direction of a5 cap here and the direction of a5 cap here, both are different. So in that case you cannot perform directly this addition operation, right? Okay, suppose if I have defined this b bar at phi 2 equal to 30 degrees. Let us assume I have defined this phi 2. Let us assume I have defined this phi 2 also at 30 degrees here. Let us assume I have defined it at 30 degrees. So that means I have to draw a parallel to this one. Okay, so like this, right? Okay, so now in this case, this will become arrow cap. So this arrow cap and this arrow cap both are parallel and this will become a5 cap. So here this a5 cap, both are parallel and here this is az cap. So this az cap and this az cap both are parallel. So in this case you can add these two vectors, whatever the vector that I have defined at this point and whatever the vector that I have defined at this point, you can add those two vectors directly. Understood? Because phi value here and phi value here, both are what? Both are same. So if phi values are same, the direction of arrow cap and the direction of a5 cap and the direction of az cap, all are what? All are same, right? Okay, okay. But here in our problem, I have mentioned this phi 2 as what? Phi 2 as 60 degrees, right? This phi 2, I have mentioned it as 60 degrees. So you cannot directly add these two vectors, right? Okay, okay. So what is the reason? Because the directions of aero cap and a phi cap in both the cases are different. So that's why you cannot add these components directly, right? That is the reason. Okay. So now how we can perform the addition operation in this case? The problem is both aero cap directions are different, both a phi cap directions are different. So that's why we cannot add them directly, right? So if you convert this vector a bar into rectangular coordinate system, and if you convert this b bar also into rectangular coordinate system, okay, then what happens here? Then here you are going to get x component, y component, z component. Here also you are going to get x component, y component and z component. So once we convert that into rectangular coordinate system, then we know that the x component direction, whether it is a bar or b bar, the x component direction will be always same. So you can add directly x components, and you can add directly y components, and you can add directly z components. Okay, so if you want to add these two vectors, what you have to do? You have to convert that vector into rectangular coordinate system. So at point 3 comma 30 degrees comma 4, I have defined a vector a bar is equal to 2 aero cap plus what? Plus 3 a phi cap plus what? Plus 4 az cap, right? Okay, at 3 comma 30 comma 4, 2 aero cap, 3 a phi cap plus 4 az cap, and at point another point at point 4 comma 60 degrees comma 5, right? Okay, so at point 4 comma 60 degrees comma 5, I have defined another vector b bar. Another vector b bar is equal to 3 aero cap, 4 a phi cap plus 5 az cap, 3 aero cap plus 4 a phi cap plus what? Plus 5 az cap. Okay, so this is in cylindrical coordinate system here. This is in cylindrical coordinate system. I have represented the vectors in cylindrical coordinate system. So rho component, phi component and z component. Rho component, phi component and z component. Okay, okay. So now how we can convert this into rectangular coordinates? How we can convert that into rectangular coordinates? So in rectangular coordinate system, so I can represent the rectangular coordinate system. What are the components you are going to have? You are going to have the x component, right? So x component plus what? Plus a y component, right? Plus a z component, plus z component, right? Okay, so this is nothing but what? This is nothing but x component of the vector, and this is nothing but y component, and this is nothing but z component, right? So how you can determine this x component here? How you can determine the x component? See, take this vector here, take this vector a bar. Okay, so take this vector a bar and try to determine its component. Try to determine its component along x direction. Then you are going to get x component. And take this vector and try to determine its y component. Then you are going to get ay. Take this vector and try to determine its z component. Then you are going to get az. So anyway, here the z component here and the z component here, both are what? Both are same. Understood? In cylindrical and rectangular, the z component will be what? The z component will remain same, right? Okay, okay. So we try to do that, right? So if you want the x component of, if you want the x component, what you have to do? So take the vector and determine the component along x direction. So how to determine the component along x direction here? What you have to do? Just to do the dot product with a unit vector along x direction. So then what you are going to get? So a cylindrical is nothing but what? Is nothing but what? Is nothing but what you are having. So here, okay, I will okay, so here Okay. So here I am representing this 2 with a rho 1 and this 3 with a phi 1 and this 4 with a z1, and here this 3 with a rho 2 and this 4 with a phi 2 and this 5 with a z2, right? Okay. So I am trying to get the general expression here, right? So a cylindrical dot what? Dot ax cap will give you x component. So a cylindrical is nothing but what? Is nothing but a rho cap plus what? Plus a phi cap plus what? Plus az cap dot what? Dot ax cap, right? This is going to give you the x component of the vector. Now here we know that this arrow cap here, we know that this arrow cap is nothing but what? Is nothing but cos phi ax cap plus what? Plus sin phi ay cap, right? And this a phi cap is nothing but what? Is nothing but minus sin phi ax cap plus what? Plus cos phi ay cap, right? Okay. Okay. So now if you do the dot product with ax cap here, okay, we know that ax cap dot ax cap will be 1, ax cap dot ay cap will become 0, ax cap dot az cap will also become 0. So what you are going to get? Tell me. Only multiply only multiply ax cap terms here. That's it. Okay. So what you are going to get here? A rho into cos phi. So you are going to get a rho into cos phi, right? So ay cap dot ax cap will become 0. Next, what you are having? A phi into what? Minus sin phi. So you are having minus a phi into sin phi. Ax cap dot ax cap will become 1. Ay cap dot ax cap will become 0. Az cap dot ax cap will become 0. So this is ax we got. So ax we got it as what? A rho cos phi, minus what? Minus a phi sin phi. This is ax value. Right. Next, ay value. Similarly, you can determine ay value. So ay is equivalent to what? What you have to do? Take the vector, and you have to determine the component of this vector along y direction. So that is a bar dot what? Dot ay cap. A bar dot ay cap. Right. Okay. Okay. So that means here a rho cap plus what? Plus. So this is a rho 1, a phi 1, az1, right? So a rho 1, a phi 1, right, plus az1 dot what? Dot ay cap. So if you do this, what you are going to get? Tell me. So again and again there is no need to write here. Here a rho cap is nothing but cos phi ax cap plus sin phi ay cap. Just multiply y components here. Right. So here you are having a rho 1 into sin phi dot what? Dot ay cap. Right. So you are going to get a rho 1 into what? Into sin phi. Right. Next, a phi 1. So ax cap dot ay cap will become 0. So ay cap dot ay cap will become 1. So a phi 1 into cos phi 1. Right. Okay. So what you are going to get here? So a phi 1 into cos phi. So that is a plus a phi 1 into what? Into cos phi. Okay. So here cos phi 1, sin phi 1, cos phi 1. So phi 1, rho 1, phi 1. Okay. So phi 1, phi 1. So let's represent in this manner. Right. Okay. So this is nothing but what? This is nothing but ay. This is nothing but ay. Right. Next, what is az here? Az. You can write directly az here. Az is equal to what? So it's the component of along z direction, that is a bar dot what? Dot az cap. So if you do the dot product, with az cap, what you are going to get? You are going to get simply az1. Understood? Okay. If you do the dot product with az cap, you are going to get directly az1. You are going to get simply az1. Right. Okay. Okay. So this is nothing but az. Az is nothing but az1. So so the vector in rectangular form here, the vector in rectangular form is equivalent to what? Ax into Ax cap. So Ax value is how much here? A rho 1 cos phi 1 minus A phi 1 sin phi 1. So A rho 1 cos phi 1 minus what? Minus A phi 1 sin phi 1 into what? Into Ax cap, right? So this is Ax, this is Ax, right? Plus plus what is y component? Y component is A rho 1 sin phi 1. This rho 1 is subscript here, okay? So A rho 1 sin phi 1 plus what? Plus A phi 1 into cos phi 1 into what? Into Ay cap, right? Okay, so this is nothing but Ay Ax1 and this is Ay1. Next plus so Az1 is same as what? Is same as Az1 only, right? Okay, so this is how you have to convert the cylindrical into what? Into rectangular. So here they have given, just substitute the values here. So A rho 1, we know that A rho 1 value is what they have given here? A rho 1 they have given as 2 and phi 1 is 30 degrees, A phi 1 is 3 and phi 1 is 30 degrees, and A rho 1 is 2, phi 1 is 30 degrees and A phi 1 is 3, phi 1 is what? Phi 1 is 30 degrees and Az1 is 4. Az1 is 4. Okay, so Az1 Az cap, right? So if you just substitute these values, you can convert that into rectangular coordinates, right? So similarly you can determine for B bar here. Similarly you can determine for B bar, right? So if you take a B bar cylindrical dot what? Dot Ax cap, you are going to get what? You are going to get Bx2, okay, or Bx, okay? You can simply represent Bx. And similarly B bar cylindrical dot what? Dot Ay cap, you are going to get what? You are going to get By, and B bar cylindrical dot what? Dot Az cap, you are going to get what? You are going to get Bz. So whatever we have done in the same manner, you can perform this also. Then you can write a B bar rectangular, you can write it as what? You can write it as Bx Ax cap plus what? Plus By Ay cap plus what? Plus Bz Az cap. So once you represent in this manner, then you can add this A rectangular and B rectangular. Understood? Okay, so you can add this x components directly and this y components directly and z components directly, right? Okay, so here I have explained the procedure how to do this one, right? Okay, so what you will do is just follow the procedure and try to determine this B bar in rectangular form, then you can add these two, right? Okay, yeah. So I hope you can do this one here. Just substitution, that's it now, right? Just substitute the values, then you are going to get the answer, right? Okay, so here solving the problem is not important. What is important is what is the procedure that we have to follow, right? So what is the concept, why we should not add these two directly? So these things are very, very important, right? Okay, yeah. Right. So now see here. So we got here, if you observe, we got here Ax is equal to what? We got here Ax is equal to A rho cos phi minus A phi sin phi. So I am writing in general here. Ax is equal to, we got A rho cos phi minus A phi sin phi. Next Ay is equal to what we got? Ay is equal to A rho sin phi plus A phi cos phi. A rho sin phi plus A phi cos phi. So this is Ay we got, and Az is same as what? Az is same as Az. Okay, so this you can write in matrix form here, that is ax, ay, az is equivalent to what? Is equivalent to, I can write here cos phi minus sin phi, and here 0, and here sin phi cos phi 0, and here 0 0 1. So this multiplied by what? This multiplied by a rho, a phi and az. So I can write the above equations in matrix form in this manner, isn't it? Okay, okay. So we can convert, we have converted the cylindrical. If the vector is given in cylindrical coordinate system, then we can convert that into rectangular coordinate system. See, there is no need to remember all these things here, just follow the procedure, right? Okay, so it is always safer to follow the procedure. So if you remember this as formula, right, so there may be a chance that if you miss a plus or minus sign also, so in place of cos if you put sin, then also the answer is going to be wrong. So instead of this, you can follow the procedure here, you can follow the procedure, that is the best way, right? Okay, okay. So now see here, so from this here, if suppose they have given the vector in rectangular coordinates, if they have given the vector in rectangular coordinates and asked to determine in terms of cylindrical coordinates, then what you have to do? The same procedure. See, they have given in rectangular coordinates like this is equal to ax cap plus what? Plus ay cap plus what? Plus az cap. They have given like this, right? And they have asked to convert into cylindrical coordinate system. So in cylindrical coordinate system, you are going to have rho component plus what? Plus phi component plus what? Plus z component. Suppose they have given to convert into cylindrical. So what you have to do? So in order to convert into cylindrical coordinate system, what you have to determine? You have to determine the rho component, you have to determine the phi component, and you have to determine the z component. So in this case, how you can determine rho component? A rho component is equivalent to what? Is equivalent to a rectangular dot what? The component of this vector along rho direction, that is a rho cap. So similarly, a phi is equal to what? Is equal to a rectangular dot what? Dot a phi cap, right? And az will be same as what? Az will be same as az only. Okay, so you can take the vector and do the dot product with az cap. You are going to get az only, right? So this is the way to convert. This is the way to convert the rectangular coordinates into what? Into cylindrical coordinates, right? So the same procedure we can follow for spherical coordinate system also. The same thing here. If suppose they have given in terms of spherical, okay, so that is ar cap plus what? Plus a theta cap plus a phi cap. Suppose they have given like this. So if you want to convert this into rectangular, if you want to convert this into rectangular, how you can convert here? Tell me how you can convert. So if you want to convert this into rectangular, so a rectangular is equal to what? Is equal to ax cap plus what? Plus ay cap plus what? Plus az cap, right? So here ax is equal to what? Ax is equal to a spherical dot what? You have to determine the component along x. So do the dot product with unit vector along x. So ay is equal to what? Is equal to a spherical dot what? Dot ay cap. And az is equal to what? Az is equal to a spherical dot what? Dot az cap. So this is going to give you the z component. Understood? And if you want to convert from rectangular to spherical, so then ar is equal to what? Ar is equal to a rectangular dot what? A rectangular dot ar cap. And a theta is equal to what? A rectangular dot what? Dot a theta cap. And a phi is equal to what? Is equal to a rectangular dot what? Dot a phi cap, right? Okay, we know the expressions here. We know the expressions for ar cap, a theta cap and a phi cap, right? We know, yes or no? So ar cap is nothing but what? Ar cap is nothing but what? see, I have already explained how to represent AR cap. Okay, so AR cap is nothing but what? Is nothing but sin theta cos phi AX cap plus what? Plus sin theta sin phi AY cap, right? Plus cos theta AZ cap. So here A bar is going to have X component, Y component and Z component. Do the dot product between these two, you are going to get AR. Right. So similarly here A theta cap is nothing but what here? A theta cap is nothing but cos theta cos phi AX cap, right? Plus cos theta sin phi AY cap, right? And then minus sin theta AZ cap, minus sin theta AZ cap, right? And here A phi cap is nothing but cos minus sin phi AX cap plus what? Plus cos phi AY cap. Just do the dot product between these two, you are going to get that one, right? Okay, okay. So I hope you can do this one here, right? Okay, okay. So I'm moving on to the next page. See here. So we got here for I have represented in a matrix form, right? Okay. See, I don't prefer to remember this one here. You just follow always the procedure. Okay, that is always best way to convert from rectangular to cylindrical and cylindrical to rectangular and spherical to rectangular or rectangular to spherical, right? That is the best way, right? Okay, okay. So now here, see here. So if you want okay, so here if you want arrow A phi and AZ here, if you want arrow A phi and AZ, if they have given in rectangular, then what you have to do? So if you want arrow A phi AZ, then take this matrix to that side, then you have to determine what? Inverse of this one, right? So then you are going to have cos phi minus sin phi 0, and here sin phi cos phi 0, 0, 0, 1, 0, 0, 1. Okay, whole inverse into what? Into AX, AY, AZ. Okay, so you have to determine the inverse of this matrix. So you can write in the matrix form in this manner, right? Okay, okay. So but what I am saying is, don't remember this matrix and all, so always follow the procedure. That is the best way, right? Okay, okay. Since in textbooks they are representing this in terms of what? In terms of matrix form. So by seeing that, you should not confuse here. You should not confuse. So that's why I am giving these matrix forms. Okay. So there is no need to remember this. We know how we got these expressions, right? So just follow the procedure, right? Okay, okay. So just for formality, I have given the matrix form in for cylindrical to rectangle and rectangle to cylindrical, right? Okay, okay. Now similarly I will give the matrix form in case of what? Spherical to rectangle and rectangular to spherical. So that is a spherical, let us say a spherical is equal to AR cap plus what? Plus A theta cap plus what? Plus A phi cap, right? So if you want to convert this into rectangular, right? So that is equal to, so AX cap plus what? Plus AY cap plus what? Plus AZ cap. So if you want to convert this spherical into rectangular, how we can do that here? How we can do that? Tell me. So what I have told, a spherical dot what? Dot AX cap is going to give you what? Is going to give you AX. So if you do this, what you are going to get? Tell me. So here a spherical is nothing but AR cap plus A theta cap plus A phi cap multiplied by what? Dot AX cap. Okay, so we know that this AR cap here, this AR cap is nothing but what? Is nothing but sin theta cos phi AX cap plus what? Plus sin theta sin phi AY cap plus what? Plus cos theta AZ cap, right? And similarly we know this A theta cap is nothing but what? Is nothing but cos theta cos phi AX cap plus what? Plus cos theta sin phi AY cap minus sin theta AZ cap, right? And we know A phi cap is nothing but what? Minus sin phi AX cap plus what? Plus cos phi AY cap, right? Okay, so we know this one here. So if you want AX, so you have to do the dot product with AX cap, yes or no? So just multiply only X components here, just multiply only X components. Okay, so then you are going to get AX. So that is equivalent to what here? That is equivalent to what you are going to get? You are going to get AR into what? Into sin theta cos phi plus what? Plus A theta into cos theta cos phi, next minus A phi into what? Into sin phi. So this is AX. So this is what you are going to get. Understood? Okay. So I hope it is crystal clear here. This is AX, right? Okay. Now similarly, if you want AY, right? So if you want AY, what you have to do? A spherical dot what? Dot AY cap. So that is equal to AR cap plus A theta cap plus A phi cap dot what? Dot AY cap. So just multiply the Y components here. Just multiply the Y components. So what you are going to get? Tell me what you are going to get. Just multiply the Y components. Okay. So what you are going to get? AR into sin theta sin phi. So AR into sin theta sin phi. Next A theta into cos theta sin phi plus A theta into cos theta cos phi, right? Sorry, cos theta sin phi, cos theta, A theta into cos theta sin phi, right? Okay, so cos theta sin phi, and here AR into sin theta. Sorry, wait. Okay. Okay, so sin theta, cos theta into sin phi, right? Okay. So next, Y component, consider Y component, A phi into cos phi. So plus you are going to have A phi into what? Into cos phi. So this is nothing but what? This is nothing but Y component, right? Right. Now similarly, if you want to determine Z component is equal to what? A spherical dot what? Dot AZ cap. Okay. So that is AR cap plus A theta cap plus A phi cap dot what? Dot AZ cap. Okay. Now just multiply the Z components here. Okay. So here the Z component is cos theta. So AR cos theta AZ cap dot AZ cap. So you are going to get AR cos theta, right? Next, A theta into minus sin theta. So you are going to get minus A theta into sin theta. Next, here you are not having any Z component, right? Okay, so that's it here. So AR cos theta minus A theta sin theta. So this is nothing but what? This is nothing but AZ. Okay, yeah. So this is AZ. So we got AX AY and AZ. So we can represent these three in terms of what? In terms of matrix form, right? Okay. So how we can represent? See here. So AX, AY, AZ is equal to what? Is equal to. So how we can represent? Sin theta cos phi, cos theta cos phi minus sin phi. So here you are having sin theta cos phi, cos theta cos phi, cos theta cos phi minus sin phi, minus sin phi. Okay, so here it is AR, A theta, A phi. Okay. Right. Next equation AY. So AR sin theta sin phi, cos theta sin phi and cos phi. Sin theta sin phi, cos theta sin phi. So what you are having? Sin theta sin phi. So sin theta sin phi and then cos theta sin phi, cos theta sin phi and then cos phi, right? So cos phi. Next AZ is equal to, here you are having cos theta and here you are having minus sin theta. Okay, so AZ is equal to AR cos theta minus A theta sin theta, right? Okay, so here it is 0. That's it now, right? Okay, so similarly if you want AR A theta A phi, okay, then what you have to do? Take the same matrix here, take the same matrix whole inverse multiplied by what? Multiplied by AX, AY and AZ. Okay, so take the same matrix here, take the same matrix here and take the inverse and write down here AX, AY, AZ. Okay, so but I don't prefer to remember this in matrix forms. I always prefer to follow what? To follow the procedure, right? Okay, so that is the best way, to get the answers. So anyway, up till now they have not asked by giving the vector in a rectangular form and asking to convert into cylindrical. So like that they have not asked up till now in GATE exam. Understood? So don't worry about that. So this is just you must have some, at least some minimum knowledge about these things. So that's why I have explained all these things, right? Okay, so I hope it is crystal clear here. I hope it is crystal clear. So after completion of this lecture, try to practice this, okay, then you are going to get the crystal clarity, right? Okay, 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 right? So with this I am ending up this lecture here. With this I am ending up this lecture, right? Okay, okay. So with this I am ending up this lecture. So with this we have completed the coordinate systems topic. So we have completed rectangular coordinate systems and we have completed cylindrical coordinate systems and also we have completed spherical coordinate systems and also we have solved some problems based on these coordinate systems, right? Okay, okay. So the applications of these coordinate systems we are going to see as we enter into the subject. As we enter into the subject, we will see the applications of these coordinate systems. Understood? Okay, okay. So just here we are building up the mathematical foundation, right? Okay, we are getting familiar with the mathematical language. So once you get familiar with this mathematical language, then you are going to enjoy the movie EMTL, right? Okay, okay. So I hope this lecture is crystal clear, right? Okay. So with this I am winding up this session. I am ending up this session. right? So okay then, take care, bye bye.